A perfect ring of teeth marks wraps around her chest. 30-plus punctures deep enough to still weep in the December water. The female measures 15 feet nose to tail. Photographer Jalil Najafov hangs 30 feet away, camera raised, watching a wound shaped like a target on an animal too big, too armored, too dangerous for almost anything alive to touch. Somewhere in the last few days, something clamped down on her hard enough to leave that mark. Nobody saw it happen. Nobody ever does. This is Isla Guadalupe, Mexico, a volcanic island 250 kilometers off Baja California, and it is one of the only places on Earth where large adult great white sharks gather in predictable numbers, drawn in by dense colonies of elephant seals and fur seals. Divers come by the boatload every autumn to watch them circle steel cages, cameras rolling almost constantly from September through December. Researchers have tagged sharks here for more than 2 decades, logging thousands of individual sightings and building family trees of animals that people around the world now recognize on sight, by name, by scar pattern. And still, when Najafov posts his photograph, the shark world cannot agree on what it shows. For an animal with a fully sequenced genome, a social media following in the millions, and more than 21,000 combined days of satellite tracking data, that disagreement points to the strangest gap in modern marine science. Nobody has ever filmed a great white shark mating. Not once, not anywhere, in over a century of organized shark research. Individual sharks have become minor celebrities, tracked live on public maps, their positions pinging in real time whenever a dorsal fin breaks the surface long enough to trigger a satellite tag. People follow specific animals online the way they follow athletes.
And despite all of that attention, all of that data, the most basic event in a great white's entire life cycle has never once been caught on camera. Today, we find out how scientists have built an entire case for how, when, and where the ocean's most famous predator reproduces, using nothing but scars, tracking pings, and a single dead body. Great whites do not behave like animals that want to be caught in the act. Adults are mostly solitary, crossing entire ocean basins alone, meeting other sharks only in passing at feeding grounds where seals haul out in numbers. Females grow larger than males, sometimes reaching 6 meters and over 2,000 kilograms, built heavier through the trunk to survive whatever comes next. They do not tolerate close company for long outside of a hunt.
Juvenile males, by contrast, arrive at aggregation sites like Guadalupe in loose, competitive groups each July, testing decoys and lunging at bait lines at speeds close to 50 kilometers an hour, long before the big adult females show up later in the season. Even telling a mature male from an immature one takes a trained eye. Researchers judge sexual maturity by how calcified and rigid a male's claspers have become, and whether they rotate freely enough to angle forward, a slow hardening process that plays out over years, invisible from a boat unless a shark is caught and examined directly. Whatever courtship happens between the fully mature adults happens fast, and it happens somewhere researchers have not yet managed to put a camera. The first real clue came from reading skin instead of watching behavior. Scott Anderson, a shark researcher with the California White Shark Project, has spent decades photographing individual sharks off Central California, building an archive of the same animals returning year after year, each one carrying a slightly different set of scars. Working with colleagues, he helped build a formal system for classifying those marks. Crescent-shaped bite scars from other white sharks, perfectly round bites from cookie-cutter sharks, pale scrapes from boat strikes, and a category researchers call hold bites, shallow, repetitive punctures clustered on the head, gills, and pectoral fins of adult females. The theory was simple. In many shark species, males bite down on the female to keep from being thrown off during copulation. Find fresh hold bites, and you have found evidence that mating happened nearby. Except the bites Anderson's team keeps photographing are never fresh.
By the time a female surfaces off the California coast carrying hold bite scars, Anderson notes, they are already mostly or completely healed. Weeks old, sometimes months. Which means whatever happened to that shark did not happen where anyone was watching. It happened somewhere out of sight, and by the time the evidence surfaces, so to speak, the crime scene is long gone. Guadalupe Island offered the next piece of the puzzle. Marine biologists Michael Domeyer and Nicole Nasby-Lucas began tagging sharks there in 1999, eventually building one of the most detailed individual shark databases in the world, tracking animals like Lucy, a 17-foot female with a permanently damaged tail, and Deep Blue, a shark estimated at 6 meters long and 50 years old. Their years of data revealed something odd about the adult females specifically. Mature females do not show up at Guadalupe every year.
They arrive every other year, often carrying fresh gashes around the gills and pectoral fins, sometimes visibly swollen through the abdomen. Skip a year, and the shark that returns looks like she has been somewhere rougher than a feeding ground. The pattern fit a 2-year reproductive cycle almost perfectly. Domeyer's hypothesis: Guadalupe itself, or the waters immediately around it, functions as a mating site, not just a hunting ground built around elephant seals. It should have been the answer. Instead, it became an argument. When the Jaffov's photograph of the 15-foot female went public and spread quickly across social media, shark experts split almost immediately over what her wound actually meant. Tristan Gutteridge, a behavioral ecologist who has spent years studying shark social behavior, looked at the healing pattern and the shape of the injury and doubted it was mating-related at all.
Mating scars, he argued, tend to be more superficial than that, closer to scraping than tearing. And this wound looked more like an attack from a rival shark than a hold bite from a courting male. Its position and depth all wrong for the pattern researchers usually associate with courtship. Michael Domeyer, the same researcher behind the Guadalupe mating hypothesis, agreed it was competitive aggression rather than courtship, though he noted that white sharks are wide-ranging animals without fixed territories to defend, which only deepens the mystery of what could have triggered a bite that severe in open water in the first place. Two of the field's most experienced researchers, looking at the exact same photograph, reached opposite conclusions about its cause within days of each other.
If experts cannot agree on what a fresh wound means from a clear, well-lit photograph, the odds of anyone confidently identifying an actual mating event from a boat deck in murky water in real time are close to zero. To understand why any of this requires biting in the first place, the story has to leave behavior aside for a moment and go straight to anatomy. Male sharks do not have a single reproductive organ. They have two, called claspers, modified extensions of the pelvic fins. In an adult male great white, each clasper is a heavily calcified, scroll-shaped structure roughly 35 to 40 centimeters long and 5 to 7 centimeters across, tipped with a hard, conical, dentine-covered spur.
During copulation, the male bends one clasper forward and inserts it into the female's cloaca, and the spur folds outward to lock the clasper in place, anchoring it against her muscular contractions, while a groove running the length of the structure channels seminal fluid into her reproductive tract, propelled by muscle contractions of his own. Because the female is frequently larger and always at least as powerful as the male, and because the whole encounter has to hold together in open water with nothing to brace against, the male needs a second point of contact, strong enough to keep two of the ocean's largest predators locked together. That second point is his mouth. The hold bite is not aggression bolted onto mating as an afterthought. It is closer to rigging, the only anchor available that is strong enough to finish the act before the pair drifts apart. Just when the Guadalupe theory looked settled, satellite tracking pulled the rug out again.
Tags recovered from sharks at both Guadalupe and Central California revealed that adults, males especially, disappear for months at a time into a region of open ocean roughly halfway between Baja California and Hawaii, an area researchers named the Shared Offshore Foraging Area, known informally as the White Shark Café. Down there, sharks dive repeatedly to depths of 300 to 500 meters, far past sunlight, far past any camera rig, in water too deep and too remote for boats to follow for long. The original explanation for that behavior was simple hunger, sharks descending toward a layer of deep-water squid and fish that rises and falls with the sun. But mature females frequently return to that same offshore zone only every other year, curiously aligned with the same reproductive rhythms seen at Guadalupe. And that timing is difficult to explain by appetite alone. Which raises an uncomfortable possibility for the mating hypothesis researchers had spent 20 years building. What if the real event isn't happening at the island at all, and Guadalupe is only where the sharks show up afterward, already scarred and already pregnant, while the actual encounter takes place hundreds of kilometers offshore, in water half a kilometer deep, permanently out of reach of any research vessel, camera crew, or cage dive? Genetics added one more twist nobody was expecting. When researcher Charlie Gubili and colleagues ran DNA analysis on the only known litter of great white shark pups available for testing, using 7 genetic markers to compare each pup against its mother, the results showed the litter had more than one father. A single female, a single pregnancy, and multiple males contributing sperm to the same brood, a pattern already documented in dozens of other shark species and known as polyandry. In some of those related species, more than 80% of litters carry the genetic signature of 2 or more fathers, sometimes as many as 5. That single result reframes the entire mystery. Scientists are not just trying to find one hidden mating event between one male and one female. They may be looking for an unknown number of separate encounters with an unknown number of partners spread across a pregnancy that already lasts more than a year, all happening in the same dark, untracked stretch of ocean. The closest anyone has come to hard proof of what actually results from all of this did not come from a dive boat. It came from a dead shark. A rare pregnant female, caught rather than filmed, yielded a litter on the order of 14 embryos and remains one of the only direct looks scientists have ever had at what develops inside a gravid great white. Combined with growth rate data, researchers estimate gestation lasts somewhere between 14 and 18 months. An extraordinarily long pregnancy, reconstructed almost entirely from indirect evidence. Because nobody has ever tracked a single female from conception through to birth. What was growing inside that female turned out to be its own kind of contest. Great white embryos are oophagous, meaning that once they exhaust the nutrients in their individual yolk sacs somewhere in the first months of gestation, they continue feeding inside the uterus by consuming unfertilized eggs their mother keeps releasing throughout the rest of the pregnancy. A continuous supply line of yolk-rich capsules instead of a placenta. Researchers studying related species suspect the largest, strongest embryos may outcompete weaker siblings for access to that food supply before birth, growing faster and larger at the expense of littermates sharing the same uterus. A great white pup does not arrive in the ocean as a blank slate. By the time it draws water through its gills for the first time, at over a meter long and already capable of hunting fish on its own, it has already spent well over a year in a straight competition for calories against its own brothers and sisters, born only after surviving its first fight. Long before satellite tags or DNA sequencing, naturalists were already struggling with the basic question of how sharks reproduce at all. Aristotle, writing in the 4th century BCE, was among the first to record that certain sharks give birth to live young rather than laying eggs like most of the fish he dissected, a claim that unsettled the neat categories he was trying to build and took centuries to be taken seriously again by later scholars who assumed, wrongly, that all fish laid eggs without exception. It was not until 1949 that researchers Perry Gilbert and Eugenie Clark achieved something that, for sharks generally, remains rare even today. They directly witnessed and documented nurse sharks copulating in shallow water off the Florida Keys. The first confirmed observation of mating behavior recorded in any shark species anywhere. Nurse sharks are slow, coastal, and comparatively easy to follow for hours at a time in clear, shallow water. Great whites are none of those things, and 3/4 of a century later, the species that Gilbert and Clark helped open the door on remains the one still locked outside it, still guarding the same secret that stumped Aristotle more than 2,000 years earlier. A common assumption trips up almost everyone who searches for this topic online, that somewhere, on some ocean documentary or leaked diver footage, real video of great whites mating already exists. It does not.
Every viral clip claiming to show it has turned out, on closer inspection, to be something else entirely. 2 sharks swimming in tandem during a feeding frenzy. A male shadowing a female in what looks like courtship, but is really just parallel travel toward the same seal colony. Or footage of an unrelated, smaller shark species mislabeled for clicks and reposted under a great white's name. Documentary crews with permits, funding, and years of open water access at known aggregation sites have never captured it either. Not from a cage, not from a drone, not from a submersible. No verified video and no confirmed photograph of the act itself exists in any scientific archive anywhere in the world. The absence is not a failure of searching hard enough. It is a fact about the animal, and about how completely the open ocean can still hide something as large as a 6-meter shark. So the case scientists have assembled stands entirely on circumstantial evidence, and by any honest accounting, it remains incomplete. The healed hold bites tell researchers mating happens somewhere sharks cannot be watched. The Guadalupe data tells them adult females follow a 2-year reproductive rhythm tied to fresh wounds. The offshore tracking tells them that same rhythm might belong somewhere else entirely, 500 meters down, in open water no camera has ever reached. The clasper anatomy tells them why the bite has to happen at all. The DNA from a single litter tells them more than one male may be involved. And one dead pregnant female tells them what a great white pregnancy ultimately produces: 14 or more pups, born after a year and a half of hidden gestation and a fight for survival that starts before birth. Every piece fits neatly against the others, and not one of them is the thing itself. There is something almost humbling about that gap.
Humanity has mapped the seafloor, sequenced the great white's entire genome, and tracked individual sharks across tens of thousands of kilometers of open ocean. And the most feared predator on the planet has still never once been caught, on camera, in the single act that keeps its species alive. A shark that appears constantly in beach warnings, in blockbuster films, in millions of hours of cage dive footage, still manages to conduct the most important event of its life somewhere no lens has ever reached. It is a reminder that fame and understanding are not the same thing. That an animal can be the most photographed predator in the ocean and still remain, in the ways that matter most, almost entirely unknown. Every July, The sharks start arriving back at Guadalupe Island, one by one, out of the deep blue water. And some of the females will be carrying scars that were not there the season before. Nobody will have watched how they got them. That, for now, is still the only proof anyone has.